Folks, my name is Rob. I'm an engineer at Hasura, and I am your host for the community call today, this August edition. Welcome. We're happy to have all of you here. I'm going to go ahead and jump over to our agenda. And as you can see, per usual, we have a lot going on today. We're going to kick it off with some updates on Mongo, and then you can see us going all the way through and ending with that community demo from a group called Div Brands with our friend Gus. So without further ado, let's go ahead and jump into it. As a reminder, if you have any questions along the way, throw them in the chat on the right-hand side. Presenters that are here will be able to answer questions either live or they'll follow up with you folks in the chat over on the right. So let me bring Martin up onto the stage real quick, and we will get started. Martin, how are you?
I am absolutely wonderful. Hey there, everyone.
Would it be fair to say that you have a collection of updates for us around Mongo today?
I do have a collection. Also, part of that update is that our documentation is also updated. We're being very funny here today. But yeah, we're really excited. We got the 1.0 of Hasura going out. It's got really nice read support. The system is going to be really interesting. I'm going to give a quick demo of it. I said I would keep it short because we have shown a bunch of this previously. So yeah, we're just going to jump right into it. I'll give a quick demo of what we're looking at, and then and yeah, like one of the big things, anybody who has any questions at all, feel free to put them in the right-hand sidebar, and I'm happy to go through anything with anybody after I'm finished show and telling. So the core features, we've really looked to approach reads really aggressively in the V1. V2 is coming out pretty soon. We're going to be doing mutation support for that. But for this version, we're going hard on reads. So the biggest part for us was query planning and composition. So the cross-collection joins, permissions, and OSI ad hoc queries, having all of those pushed down to the database. So that is a performance system has been kind of like top priority for us. And that's really important. Like from our side of things, that's really what we've talked to a lot of our customers about and seen a lot of feedback that people really appreciate from our side is how we can layer on all of these elements while still keeping the query's performance. So I'll show some of that and we'll be able to talk about it in a couple seconds. But then also having the ability to use the right tool for the right job and join data between external data sources and have that ability to say that like, hey, I have like, a loyalty database over in Postgres. I've got my transactional database in MongoDB. Like having those patterns and having like larger organizations be able to tie and mesh those data points together has also been really important in terms of like what we're looking to do for MongoDB. And then schema composition and logical models. There is no like schema in MongoDB, so we have to infer a schema and create something. So we have our first cut of that, and it's going to be continue getting better over time and how we do that. But we'll show how you can still get up to speed really quickly with your teams using MongoDB and Hasura. So let's go into the fun stuff. Let's do a demo. So we're going to connect to MongoDB. We actually have MongoDB locally, a cloud instance, and a Postgres instance locally, which we're going to connect to all at once. We're going to track a collection and generate a schema from a single document. We're then going to create a cross-collection join, add some permissions to it, and join up to a Postgres database. So I'm going to cheat a little bit. I'm going to inject some metadata at one point, but yeah, we'll do it sort of quickly. Again, I recommend you go and actually check out our docs. Really, they've just been updated. So some of the more interesting ones that have been updated are MongoDB Atlas, how to connect and stuff like that, how we support logical models in, so that's under GraphQL schema, how we support logical models in MongoDB. So that's another really important piece. And then, just all the rest of the normal stuff that we go about doing in there as well. So I've pre-connected up a local Postgres instance, a local MongoDB instance, and an Atlas instance. So within each of those, we also have some dummy data. So we're using the MongoFlix demo, which is a really nice, like kind of, you got movies, you've got comments, you've got users, all the stuff you need to build an application pretty much. We also have a loyalty table over here, which we're going to be tracking later and then doing some joins on. So let's start by tracking our first collection. So if I go to users, and then if I have MongoDB Compass over here, what we're going to do is take a sample document, like a sort of a document that we're going to be using to infer the models from. So we get this new window that comes up, and it'll allow us to create a model within Hasura, which will be used for our GraphQL schema from a single document in my database. So when I validate that, it'll really easily just take it through, analyze it, cast the types or infer the types, and then track pretty much. And that's now been added to my API. And we're able to do that pretty quickly. And all of these are customizable afterwards. So you're not sort of set with the first time you do it. You'll be able to go to the logical model window and edit these schema elements afterwards as well. So We'll do the same thing for comments. What I'm going to do is I'm going to do like sort of a user and comment mapping type of API. So again, this is some nested data. So we have a couple more models that it's creating. And what we're able to do is we've tracked those. Those are now available in my API, I believe. I haven't created a relationship yet between those. And what we're able to do is now create a relationship between the user's model and the comments model. So that'll be a one-to-many relationship. So we can come over here and create an array relationship for that. And we're going to use email as the key between each of those. So this is kind of like a mock-up demo, but you can kind of get an understanding of how you would create an API using this. Again, as we sort of create those types for you, you can come over here and edit those types as well. And without doing any migrations at all, that'll actually reflect back in both your API and also allow you to map any new elements from your database or remove elements as needed from your MongoDB Compass instance. Not Compass, but your MongoDB database. One of the interesting points about this as well, I'm currently running an E-Lite instance locally, but if you run this on cloud, we also have a fun project called Schema Registry, which will allow you to sort of check to make sure the changes that you're making are safe still, and it'll give you notifications if you create a breaking change in your API. You change something that's currently actively in use, because we don't have the migration system quite so much in MongoDB. We get to sort of do things on the fly a little bit more flexibly. So I just tracked two collections and then created a relationship between them. And then using this query, you can see that I'm now returning back all of those, all of the users and their associated comments from MongoDB. So that was really quick, really easy. Digging in a little bit deeper, I'm going to do a bit of a food network, load some metadata in so that I don't need to create the permissions and stuff. On the fly. So what we've got here is we've tracked the users and comments. We also in Atlas, in MongoDB Atlas, we're using the same database. So what I'm going to do is I'm going to track the same collection of comments, and I'm going to call it more comments because I'm not creative that way. And then what we're going to do is track a loyalty table in Postgres as well. So now we've got 3 databases, 2 locally, 1 in the cloud, and we're actually going to do that with a permission on top of it. So on the users table within my MongoDB collection, what I've done is I've added a permission role on it to say that, like, hey, email equals Hasura user ID, and then show all the columns kind of thing. And all of these are all the other ones. So comments and loyalty, I've sort of just allowed the users table to view them as needed kind of thing. So with that being said, since I have my Hasura admin secret set and my role and my user ID set, this will allow me to, let's refresh this really quick. This will allow me to emulate using the user's permission for this user ID. This would usually be passed using a JWT token or a webhook authentication. So you could pass in the context of which user is accessing the system. If I then run a query, I'm now running, this will be pushed down to the database. So name, email, comments, that'll be pushed down to my MongoDB instance. And then we'll be joining on that 2 external data sources. So more comments from MongoDB Atlas, as well as a loyalty database, which is in Postgres hosted locally. So when we run this, I should get 1 user back, which is nice, I do. This user that I've specified here, I'm able to get back their associated comments, more comments from MongoDB Atlas, and loyalty from Postgres afterwards. So that's a really quick demo of what we're doing with MongoDB Atlas. This is currently available on cloud and E-Lite as well on the self-hosted version. You can give it a try, get started with it. Feel free to ping me with any comments over in the right-hand sidebar. And coming soon, we'll also be having mutation support as well as part of our development roadmap. So that's pretty much all I had to go with today. So I really appreciate everybody's time. Thank you very much.
Martin, that was awesome. Thanks so much. If folks on the call have not checked out Martin's HasuraCon talk, was the title, it should have been Mongo all along?
It should have been Mongo all along. Yeah, it's that flexible non-migration story. I really think that it's really like the easiest way to get started.
Very cool. All right, thanks so much, Martin. And I'm going to bring on one of our technical evangelists, Simrat, who's been hard at work with a lot of people on a new concept called Hasura Notebook that's all focused on generative AI and these applications. So let me bring Simrat up real quick. Simrat, how are you?
Hey, Rob. I'm doing good.
Looks very nice wherever you are in the background there. Do you
Okay,
want to give us a little bit of an overview as to what Hasura Notebook is, and then I'll unshare screen and you can dive into the demo? Awesome.
great. So Hasura empowers you to build rapidly and like create high quality data APIs for production use cases. And what we have seen with GenAI is that data sources continue to evolve, and Hasura is evolving as well. So with GenAI, we have seen new data sources like vector DBs come in, and so Hasura is now evolving to not just enable our users to use vector DB, but also provide them with a very nice prototyping interface and a tool where they can quickly build GenAI application. And I'm like super excited to show you how you can do that. So the first, so the way you get started with all of this is that you got to be using Hasura CLI, which is where you have a plugin support for Hasura Notebook. So you can create your Hasura Notebook using a single command, which is Hasura Notebook create, and you get your notebook deployed on Hasura Infra in no time. You can check the status using the status command, and once your notebook is deployed, you are returned with an endpoint that looks something like this, and you have your username and password to the notebook. Of course, you can have a different password and make it really secure. Um, but let's get started. Let's demo this thing. So when you take the Hasura Notebook endpoint and when you run it on your browser, this is the landing page. This is how it looks like. And what what you're getting with this is basically two things. One, you have the notebook capability, which most of the Python developers working on machine learning and data science are familiar with. But there's also a very interesting part of this notebook which I want to talk about first, which is it lets you convert your code on the cells as endpoints. So let's take a look at it real quick. So when you launch the notebook, you're going to get this regular interface where you have like your files, and if you open your server file, which I'm doing here, you're going to see that there is a cell and it is commented with get and a URL that you would want this to be exposed at. So what we can do is we can say that, okay, that's the code that I want to have serve as my endpoint. Let me restart in case you have made any changes. And then you can test this out. So restart usually takes like a little bit of time because there is a refresh that is happening at the backend. So let me just give this another shot. Yeah, so there you go. So this is the code that you had in your cell, and now it's basically out there as an endpoint. You can change this and it would get reflected there, right? Um, right. So now let us start seeing, now that we understand what Hasura Notebook is, let's really quickly build something live here and see the value of it, right? So the first thing that we'll have to do is set up some Postgres data. Actually, let's talk about like what we want to build, right? So let's say I have some products, and let's say I'm an e-commerce website. I want to enable my customers to not just search for the products using keyword searches, but I want to bring in the capability of GenAI now to my search, which is to make my search a lot more smarter. So typically when you are starting off with like a use case like this, you have an application, there is a database that is powering your application, the backend database that could be on Postgres or something else. So let us assume that we have a database in Postgres, and let's say it's a very simple database which has like ID, name, and descriptions. Okay, so now that's the first part of it. Um, Description is something where we want to now enable contextual search and more smart analysis using LLM. So let's head over to a vector database because I need to store these textual these text entity somewhere so that I can fetch it really quickly and then feed it to my LLM as context, do all of that prompt engineering, and get like build something really useful. So you can use vector database of your choice. Right now, I'm going to be using VV8. Great. So when you log into VV8, it lets you set up VV8 clusters free for some, like I think 14 days. Yeah. So I have one which is already up and running. I want to really quickly show you what it gives you. So it's going to give you the cluster URL. It's going to give you the API key, and this is what we're going to be using, right? So from our homepage on Jupyter Notebook, we're gonna open setup VV8. This is already built out templated project for you to like pick it up and play around. So you basically plug in these values here. You plug in your VV8 URL, your API, and also your OpenAI key. And the reason why I'm using OpenAI's key here is because I'm gonna say that I want VV8 to vectorize my incoming text and store it. And so the way you store something in VV8 is you basically create these schemas. This is my product vector schema, and I'm having some configuration like what is my similarity metrics and some of the thresholding stuff. Um, I'm going to be querying, making my contextual searches on name and description. And the way I say that I want my contextual searches to be running on this is by saying that um, I want to vectorize this. I want to vectorize this using OpenAI embeddings. And once that is vectorized and stored in VV8, then I can do like really quick retrieval and augment my LLM queries. So this is available once you execute this cell. I can do that even right now. So once you execute this cell, you're gonna have almost like a database available in VBA. Then next, what you want to do is you want to connect this VBA data source with Hasura. So you'll have to come to the data tab, come to manage. You'll have to come here and add a VB8 agent. And I already have this, but if you have to do it like the first time by yourself, you're again going to be needing Hasura CLI, so you can create a Hasura connector for VV8. Like you can deploy using a command where you give the name and you give the GitHub repo of your connector. So I've already done that, so I'm not going to do this step again. And you can once you have connected the agent, you can very quickly also using connect database have that DB object, so you can have that and you can track that. So I have already done all of this steps, so I'm not going to do that. And yeah, and our Postgres database is also ready. So these are some of the steps that I already processed and just kept them handy because we're going to be short of time on this call. So next thing, let's say if I want to start using this vector DB for anything, I ha- I basically these vectors, if you think about, okay, let's just talk a little bit about these vector databases, right? These are a new kind of data store which stores just your vectors. They do not have any information about your data model. Like in our case, it does not have any understanding of your products, your sellers, or anything like that. And so if you want to now start leveraging this vector database in a more powerful way, you have to use Hasura to define this relationship. And let's say if you're not doing that, and if you're trying to use the extra metadata support that some of the vector DBs provide, what you're signing up for is doing a lot of data copy and data sync, and you can get into data staleness issues, and that's going to be super complicated. So the best way for us to go forward is to use a relationship where all of the application data stays in Postgres, all of the vector data stays in VectorDB. That's what they are best suited for. And we define a relationship to connect these two data sources. It's going to be an object relationship, which is like a one-to-one relationship. And once this relationship is available, I can now start thinking of really complex and interesting use cases like setting up an auto vectorization, because Hasura provides events, the event triggers that you can leverage. So the way I can do this is by going back to my server Jupyter notebook. I can define some logic here, which in this case is this handle insert, where I'm saying that every time a record, let's say a new product gets created in your Postgres table, you get that information, and um, you are having this query to write to a vector database where it gets auto vectorized. So I have set all of this up already. One interesting thing is that because this notebook is um, it has the username and password, you will have to set authorization in your header, and we have instructions on how you can get this value. So for now, I'm just going to skip through that and say that okay, we have our events ready. So now let's go back to our database state. I have Postgres table, which is empty right now. I have my vector DB, which is again empty right now. And I have some synthetic data, which is ready to be fed in. So I'm just going to run this script, okay, real time, and it's going to insert 52 rows. Let's go and look at the state of our tables. Okay, so we have 52 rows. Yep, 52 rows inserted into our Postgres. Let us look at our vector DB. Yeah, there you go. So your vector DB got updated near real time, which means if you have two functionalities on your app, they are in sync, um, at, and everything gets updated instantly. So now let's take it a step forward, and let's really go ahead and build that smart LLM search that we were talking about, right? So we would go back to our server.py where we have this templated code already available for you. Let me really quickly run you through what this does, right? So that you understand the power of this. So this is a business logic that we are creating. What we are saying here is that we're going to be we're going to expect the user to ask us a question, and on the question that the user is asking, we're going to first query a vector database, and we are going to we're going to pick 10 most relevant results, and then we are going to feed that to our LLM by creating this context. So what we are doing here is augmenting context to our LLM prompt to get like best out of the large language models. So we have this available. What I would need to do next is go to actions, create an action query out of it, which is nothing but it's a query type, takes user query as input, gives me a string as an output, and again my web hook is going to be this URL of my connector, and then we will have to suffix that with invoke and the handler name, which um, sorry, this one handler name that we defined here. It can be anything. You can define whatever handler names you want. Again, we'll have to provide the authorization. LLMs sometimes can be slow. You can set timeout based on, you can have like a reasonable timeout based on your use case. So you save all of this. I already have this ready, so not going to be saving this. And so when I come back to my API console, I see that I have this action available. Now I'm going to query for what are the most durable products in my catalog and why. So imagine like you giving your customers the power to not just search for products, now even ask more contextual stuff on top of it, right? Yeah, so there you go. There's the most durable products are the hiking backpacks, steel bottles, and some EcoFrost fridge eggs, which sounds like they're durable. And it also gives you the reason why. And it's doing all of this looking at the description. Yeah, that was for the demo.
That was awesome. I've seen this several times already. I've been part of doing some of the educational content for this, but it still impresses me every single time with what we can do inside of Hasura using these LLMs. So cool. And of course, 1,000 different things going on in my head of ways of being a little bit lazier and getting AI to do more things for me.
Yeah, and we would love to hear more feedback from folks. Yeah.
Awesome. Feedback could be thrown. Where's the best place?
Yeah, on the chat here.
Yep. And then also Discord, right? People can hit us up there and share anything as well. Yep. Awesome. Thank you so much. Next up, in a related vein, but a little bit different, I'm going to bring on Benoit in just a moment, and we are going to talk a little bit about ClickHouse, and we're going to talk about it in the context of it being a connector. So let me go ahead and bring Benoit on stage. Benoit, how are you doing today?
I'm doing fantastic. Can you all hear me? Is my mic coming through? Yeah.
We can hear you.
Yes, it is.
Before we dive into your demo, I was
Yeah,
going to
go on.
ask, could you share a little bit about what a connector is, just for those that may have not been on previous community calls and don't have too much
Absolutely.
context? Thanks.
Yes. So a connector is a service that allows a data source, an arbitrary data source, to be consumed through Hasura. In a lot of cases, these can be databases, but they don't have to be. We have connectors for text files. And you can also build a connector for an arbitrary REST API, as long as the API that you're consuming matches what we expect of a data source. So yeah, that would be what a connector is. And then you can, of course, use these connectors as a data source in Hasura, just like you would any other database.
Awesome. Let's see it with ClickHouse.
Yeah, absolutely. Let's sharing my screen. Yeah, cool. All right. So the ClickHouse connector is here. It's on GitHub. It's open source. And I have set up a project. This is going to be pretty quick because there's not much to it. But to set up a connector, you first need to deploy it. You can reference the instructions on the connector README for that. You can either deploy it on your own infrastructure, or you can deploy it on Hasura Cloud if you're going to be using it with us. That is what I've done here for the demo. So if we check here, I have added the ClickHouse connector. I've deployed it, and that's given me a URL, which I can then add as a connector. And once I've done that, I'm able to connect the database. I'm able to select ClickHouse as the data type. And then it's going to ask me for a bunch of configuration options. In this case, I'm going to actually back out of this because I've already set up the connector. So we can see it here as ClickHouse. And in this particular project, I actually have a Postgres database, which I've helpfully named Postgres, and that has an artist table. And the ClickHouse database has albums and tracks. So this here, we're doing a scenario where we are assuming that maybe we have some data that is relatively static, and we have that in Postgres, and then we have some large amounts of data that are coming in ClickHouse, and these are somehow related, and we want to be able to consume them in such a way. So that is exactly what we're going to do. Over here in our API tab, we can consume we can just consume our API. And what I'm doing here is I'm traversing the relationships. So I'm starting over in the artist. That is great. That's fun. Okay, well, I guess it's gonna not work for demos because this one works, and ClickHouse must have been asleep. Yeah, ClickHouse must have been asleep. So ClickHouse will go to sleep at about 15 minutes, I think. So yeah, it was asleep, which is why it failed a couple times, but after that, it just worked. So you can see we're consuming our artist, which is of course in Postgres, and we're also getting our albums, which are in ClickHouse. This is not the only use case. If you're already a user of ClickHouse, you can of course consume it as you would any other data source. And if you, are not a user of ClickHouse, but you're a user of Hasura and you want to use ClickHouse, this might be a way to approach it. And the only other thing I probably have to add for this demo is that this is of course for Hasura v2, but we will also have this functionality for Hasura v3.
Very cool, Benoit. Thank you so much.
I'm just going to check if there are any questions. I'm guessing no. Yeah, there are aggregates. And absolutely do raise issues as well if you have a specific use case for a specific aggregate and that's not supported. I'm aware that we may not have supported every single aggregate function, so if anybody has a specific need, feel free to raise issues on the repo and we'll get to that as soon as possible. That's
awesome.
It from me, folks.
Benoit, thank you very much. We're going to shift gears, and I'm going to bring Suraj on the stage in just a moment. We're going to talk about remote table authorization. So Suraj, let's go ahead and bring you up here.
Okay, yeah, everything's set. So hey folks, I'm Suraj. I'm a senior engineer at Hasura. So today I'm going to talk about a very interesting feature called remote table authorization. So as the name suggests, so we're basically extending the permission our authorization boundaries across the data sources. So it's not like you have a data source and you should have a authorization rule that relates to that particular data source. So we are basically crossing the boundaries. So really excited. So to give a sense of like what this feature about, so think of like a remote relationship. So basically this feature allows you to join the data across different data sources, right? So we also have permissions, which is basically the role-based access control with custom rules, right? So you can have a rule, you can define multiple roles, and then you can have custom rules on that particular table or the data source to say that this is the permission, this is the way of access control I want for this particular one. So what if these two are combined, right? So that's what exactly this feature all about. So I'm gonna get into a quick demo now. So to summarize the setup, I have a Snowflake database wherein I have a table called invoice, and then I have another database called user seed. So as you can see, these two are like sitting in different data sources altogether. And then if you look at the invoice table, what I have here is a customer ID, and some billing information. So imagine this customer ID is very specific to your payment system. Maybe it is tracked in a slightly different way. And the user table which you're having is something that comes in from the auth setup, and wherein you have an internal user ID sort of a thing. So usually what we'll do is with the remote relationship, we'll have a remote relationship configured like this. So if you want to take a look at this, this is how it is configured. The customer ID is mapped onto the invoice user ID. So to help you understand what is invoice user ID in my setup, it's a user ID which is kept on the invoice table or your third-party table. So basically, it is mapped And then when I go to the permission bit, previously what you can do is you can only have columns or local relationships as part of your permission rule. But with this setup, you can now have a remote relationship as your, the permission rule, which basically opens up a lot of possibilities. Like, for example, you want to check, hey, my authorization setup relies on the Hasura user ID, which comes from user ID of the users table. But the relationship is actually using a different ID called customer ID, right? So in that case, I don't have to specifically, use a third-party webhook or maybe a different solution to, pull the data and set up some custom rule. Instead, I can simply define, hey, use this remote relationship for my permission, and then use user ID is equal to X Hasura user ID, not the invoice user ID or customer ID. So with this simple setup, what I can do is I can simply query the invoice table with Hasura role as user and then Hasura user ID as one. So what happens is I'll just pull out the user object as well, just to help you understand how things works. So as you can see, the internal user has a user ID 1. And for this particular user ID, we have an invoice user ID called 8. Right? So on this invoice table, all that we have is customer ID is equal to 8. And for some situation, I may have to hide this, internal references and make sure that the external facing API is not really, consuming all my, or maybe it's not leaking all the external data or internal data. So in this case, what I can also do is I can simply hide, the user's permission. I'm going to delete this permission, which will make this user's table invisible to the external, GraphQL schema. So what happens is I'll not be having access to the users table. You can do it as if you want, but for the demo, I just want to show you a magic. So basically, when you query the invoice, you get all the invoices for the customer 8, but on this request, you don't have any request or any identification for user ID 8. Right? So you get all the remote. So basically, the authorization is taken from the remote table, but you're querying the simple table. And if you really want to understand how this works with Hasura, you can simply click on Analyze button. What it gives you is it gives you the generated SQL that's gonna get executed on the upstream database, and then you'll also see the actual query here. So in this query, you can see the query says invoice.customer ID in 8, right? So basically, Hasura went ahead and fetched the user ID, fetched the user table, and then it fetched the user customer ID equal to 8. So that is already included in the the actual query. So it's really interesting. You can also do things like, one level down. Say if you want to create a permission called manager, and then if you want to set up things like, hey, I want the rule to be internal user dot manager ID is equal to X Hasura user ID. So in that case, if a user has user ID, if the user is manager, then they can use the role to, specify, they can use that role to access this data without even, go doing multiple queries. So the end user will simply be querying, hey, give me all the invoices which I have access to, or maybe I can have some, conditions. So all the access across all the data sources will be taken care by the Hasura instance. And this feature is right now available on the latest version v2.33, but the console support will be added on the next release. And you will be able to access or use this feature across all the GDC based databases and Postgres data sources. With that, I'm gonna wrap up the demo. I'll be available for any questions on the chat. So thank you, folks.
Coach, that was awesome. Thank you so much. I'm sure people have lots of exciting use cases for how to implement this in their projects. Thank you. As Suraj was coming up on the stage, I was saying that we were going to shift gears and talk a little bit about V3 with an update. And instead of sharing my screen for just that slide, I'm actually going to play a video from down under because it's the middle of the night for our next presenter. And then we'll bring Rahul up on the stage a little bit later to talk about that. But when I saw this video earlier today as a demo, it blew me away, thinking about a TypeScript connector to work with Hasura. So here we go. I'm going to go ahead and play this on the stage.
Hi, this is Lyndon from the Data Connectors team at Hasura. I'm here today to bring you a little bit of a sneak peek at what we like to call the TypeScript connector. So let me open up some slides so I don't lose my place and see if we can get through this quickly enough that you've got time for some questions. So right off the top, what is the TypeScript connector? Well, we're going to call it the future of actions in Hasura v3. A bit of background. You might love Hasura. I know I certainly love Hasura and a lot of people do. But from my experience, the reason why they love it is because of two things. One is convenience and the other one is experience. So you have a very convenient time using Hasura, but you also have a great experience using Hasura. So those things don't always go together, but with Hasura, historically, they have. But nothing is perfect. And what could be improved from Hasura v2? Well, I think everyone has at one stage or another butted up against the problem of a lack of flexibility for certain things. Because Hasura is very opinionated, and there's always some way to achieve what you want to achieve, but you may not be able to do it with Hasura alone. You might need a Lambda function or something like that to help you out. So then, what is this v3 thing and what is its philosophy? So I think at the core of v3, we're trying to make things more declarative and have cleaner boundaries, but at the same time make things a lot faster and more economical and closer to the edge. So what about v2 actions? You may be familiar with v2 actions. They're one of Hasura's historically core features. They're very convenient. They let you hit a REST API, but they're not super flexible. So in the past, you may have had to write a Lambda function or a web service to be able to receive your action and translate it to another service that you want to hit or do some business logic. But actually, that may not be as convenient as you'd like it to be. And that's why we introduced Critty recently, the templating language to translate responses, but even that has limitations. So Hasura v3 is kind of in the opposite position. It's extremely flexible and powerful with a connector-driven paradigm, allowing you to do pretty much whatever you want and expose it as a data source, but it's not super convenient because you have to implement a whole kind of paradigm if you want to write your own connector. But here at Hasura, we want our customers to have their cake and eat it too. We want a convenient and powerful action alternative. So we've got this guy, not sure. If you're familiar with Idiocracy, that's where that's from. And he's going to solve everything. In this case, the TS connector is somewhat of this idea. We want to be able to let you write idiomatic TypeScript functions that can do whatever you want and have Hasura automatically infer and expose them as a GraphQL API in the engine. Wouldn't that be great? I think everyone can agree it would. So I'll give you a little demo. So here I've got a little skeleton project. Just ignore this full and stub files. I'm going to copy and paste from them. And essentially, this is the v3 format that you might be exposed to. You have a metadata kind of declaratively describing your v3 project. And then in this case, because we're going to use the TypeScript connector, we have a TypeScript function file. And if we go here and run it, then you'll see that the implementation that we've defined, currently stubs, comes through automatically. But let's have a look at a fuller implementation. And you can see here that we're actually referencing libraries rather than just having vanilla TypeScript files. and we've defined their interfaces with usual TypeScript fashion, nothing bespoke to Hasura. And now if we go over here and run them, we've got a GitHub bio lookup for me, Sordina, and we've got a password hash function of the Hunter2 password with the very secure MD5 hash. So that's pretty much all we've got time for. But this is going to let you write idiomatic TypeScript to achieve function-like capabilities. Please give us some questions.
All right, some very cool things there. I was very excited when I first saw that. Rahul, I know that you're here to talk a little bit about V3, maybe answer some questions that come through about the TypeScript connector itself. But I know you have some other things that you'd like to talk about as well. So I'll turn it over to you.
No, we really would like to know from the community how you think about this demo, and what you saw in the demo before is a kind of this flow which I'm presenting here, that you're writing functions in TypeScript, and then using the TypeScript connector, you're able to leverage the V3 engine to front those functions. And the two use cases which we saw were you calling the GitHub API to get some information, or using one of the NPM packages to do to execute a hash on a value. So these are like some of the things we would like to know from you, is that does using TypeScript for business logic or working with external APIs resonate with you, or do you think it's like okay, or are you very excited about the support of TypeScript now on Hasura? What are your ideas and concerns in general about the DX? Do you want control over the function hosting platform? For example, what if we bring in, provide some integration with Dino, or you don't want to think about Dino, you just want Hasura to manage all of that? Those are like some of the things we are want some feedback on. And just in general, what kind of functionality would you like to build with this, and any top NPM packages that come to your mind, or external APIs that come to your mind which you could use for this connector? Those are some of the things we would like to know more. So maybe let's give it half a minute or 1 minute for people to provide their feedback on what they just saw. And you could always...
Yeah, there's already a few
Yes.
pieces coming in over there.
And you can always reach out to me on this email to provide more feedback. So I know Tristan always wants something regarding Python, so we'll get there. But so you're saying that, okay, host actions, events, and crons in Hasura Cloud. Got it. Ben, thank you for that feedback. About the CI/CD and deployment story, and that's where we wanted to know more, is that do you want that CI/CD for the functions to be separate from Hasura, or do you want Hasura to manage that CI/CD? I think the latter brings some complexity. That's something, Ben, if you have any comments on that, that would be helpful. Awesome. So Peter is saying that yes, TypeScript is a good direction we're going towards. Yeah, so when you talk about type, okay, so you really see, Salem, that you could use something like this to inject business logic. That's great to know. Amazing. Thank you for providing all this feedback. I think I would want to create and test in dev and then automatically deploy into prod. Got it. Okay, Ben. Thank you for that. And so overall, this is clicking. So we'll want to invest more in this, and as we roll out V3, stay in tune for the upcoming public release, and you will get an opportunity to use this in production and execute some use cases. And awesome. So I'll reach out to you folks individually, if you don't mind, to have more chat on this. But I just want to yield my time, Rob, for the other presentations today. That's what we had for today from V3.
Rahul, that's awesome. Thank you so much. Very gracious with your time, and nice to see a lot of validation coming through in the chat about this. That's great. More times. We had two presentations left. One's going to be internal. I'm going to bring Vaishnavi on in just a moment, and we're going to talk about a new CLI plugin for federating GraphQL and CI/CD, and then we'll be bringing on our community demo with Gus here at the end of our call. So I'm going to go ahead and find Vaishnavi in my list.
Okay, perfect. Hey, folks. So today I'm going to be introducing an exciting new plugin, which is the new CLI plugin for GraphQL Federation. So I'll quickly walk through what the challenges were and why we decided to go this route, right? So as a subgraph owner or as a supergraph owner, and a lot of our users are using Hasura for GraphQL Federation and data federation, right? So as a subgraph owner, a lot of times I think about, hey, if I have a bunch of remote schemas that I'm modifying on my end, how do I make sure that this remote schema after modification is not breaking anything else in the gateway, right? So if I have a setup like this where I have different kinds of data sources connecting to a gateway setup in like a data federation or a GraphQL Federation world, how do I make sure that any edits that I make as a subgraph owner, which is owned by one team, is not affecting the gateway or anything else that any other team pushes in, right? So the primary challenge here is that how do we handle multiple teams and ownerships, and how do we handle all of this in the CI/CD space where different data sources are connecting into a gateway. So currently it's slightly difficult to build independently and make sure that all of these merges into the gateway is not breaking things, right? So currently the metadata check actually happens after merge, which means after all of this metadata is reloaded into the gateway, only then you'll be able to know whether some of the metadata is consistent or inconsistent or what's happening there. So you're having to do a whole lot of tests, and this is how the situation is right now. So I would actually want to know if any changes that I'm pushing in right now will break the gateway or will affect any other graphs in my architecture, right? So the solution to this that we've come up with is essentially extremely simple, very simple 3 CLI commands. So the check, build, and the publish command. So what the check command does is, once I'm done with the changes of my subgraph, I will be able to check if the metadata is consistent with what is in the gateway before merge, right? So this is like an extremely powerful thing for you to be able to check if any changes that you have done is going to affect anything else. Next is the build command, which essentially builds the appended metadata. So it combines your gateway metadata along with your subgraphs metadata, any new changes that are going in there. And finally, the publish command allows you to push all of these changes back to the gateway. Right, and to do all of this, you'll just need a gateway configuration file, and you'll be able to specify all of the different remote schemas, that are there in your graph and what changes you want to push into the gateway. So I'll do a really quick demo, and before that, I'm going to describe the architecture that I'm looking at here. So I have a Hasura gateway, and I have 2 subgraphs coming in as remote schemas to the gateway. Right, and so currently both of these subgraphs are essentially Hasura instances itself, but these could be any GraphQL APIs for that matter, right? So now I have the accounts table, which is going in as a remote schema to the gateway, and an orders table, which is also going in as a remote schema to the gateway. And what I want to do is I want to create a remote relationship between accounts and orders, and I'm going to do all of this using our CLI commands. So let me quickly switch in here. Before that, I want to quickly show you what the gateway configuration file looks like. So this is the gateway configuration file. This is the subgraph that I am owning. This is Hasura 1, which has the accounts table. And this is a relationship that I want to set up, right? So the account ID will map to the account ID in the orders table. And I want to quickly show you what my gateway looks like. This is my gateway. I'm doing all of this in Hasura Cloud. I have 2 of these remote schemas that are feeding in. Now, I'll show you a positive case in here. Here's my terminal. All right, so this is what the command looks like, the gateway plugin Hasura gateway, and I need to feed in the gateway URL. So this is the gateway URL that I just showed you, and the gateway configuration file, which we just went through, right? And I want to be able to give the admin secret in here, and this is the check command. So when I run the check command in my gateway configuration file, I've specified a remote relationship that's going in from accounts to orders, and right now everything is consistent. So it's checking whether the metadata of my subgraph in here is consistent with the gateway. So I'll quickly go ahead and check here. I've added a remote relationship, which we will be able to publish, right? So the next thing we will do All right. So here, if we check, currently we do not have any remote relationships. We're going to add a remote relationship with the publish command. So I'm going to build the metadata. What this is going to do is it's going to pull up the metadata from the gateway and add in, all the metadata that I've added into the configuration file and combine both of these. So if you quickly take a look at this, the gateway has another remote schema, which is Hasura 2, and this is what we had in our configuration file along with the relationship. Right now, the last step in here is I'm going to do a publish to the gateway. Now, this will essentially apply all of the metadata in my subgraph, which is Hasura 1, to the gateway. We'll also be able to check that this remote relationship has been applied. So this is published to the gateway. Now we will go check in here. So I go to Hasura 1, and there we go. So we have a remote relationship that is applied from my CLI. Now, I want to show a breaking case, right? So I go back to my gateway configuration file. Now my field is actually ID, but I'm just going to rename it to something which is not there, right? So if my team here has edited something in my subgraph, but if I do a check on the same thing, that relationship can't be made, right? So this is going to show up as inconsistent metadata with the gateway. There we go. So if you look at it here, we've added ID test, which is not there, and it cannot create a remote relationship between these two remote schemas. And this is what it showed up as, right? So please try this out, and we'd love to get more feedback on what you would like to see. How do you want to integrate this into your CI/CD pipeline? What other functionality would you like to see? So on and so forth. I'll drop my email in here. We have a bunch of documentation that's already on here. So I think the key takeaways are essentially that you will be able to check metadata apply and consistency before the deploy, and this will enable you to independently build and federate and roll out confidently. All right, thank you so much.
Always nice to deploy with a little bit more confidence. Thank you, Vaishnavi.
Thank you.
All right, folks, we have our last demo of the day coming up here. This is going to be our community demo. I'm going to go ahead and bring Gus on stage from Div Brands. Gus, how are you?
Hey, I'm fine. How about you, Rob?
Doing well. Thanks for being patient. If you're familiar with our calls, we usually go a little bit over, so here we are right now. But I'm going to turn it over to you so you can tell us all about Div Brands and about what you've done with Hasura.
Well, thank you. Hi, everyone. I'm Gus. I'm CTO of Div Brands. We are an e-commerce operator. So what we do is pretty much we have a few brands that we develop and scale them and create products and sell to customers. So we sell hoodies, tennis shoes, and supplements. And selling stuff online requires you to have an e-commerce platform. And what we've been struggling a lot is the limitations that the platforms bring in. A lot of you might be familiar with Shopify and the other likes. So we've been moving towards what is called MAC and composable architecture, which is pretty much just architectural best practices for using microservices, API, cloud native, and headless, which is good for performance, security, etc. And composable is pretty much just composing. Instead of having one big chunk of monolith for everything, you split down in many different parts and you maintain those independently. Of course, there are some challenges on this. It's not cost effective. It takes time to develop. You need to integrate multiple APIs here and there. And there's also, but there are some advantages performance-wise in event-driven systems. You can keep track of what is going on. You don't have a single point of failure, and also security, which is very important, especially if you're a merchant. You have to deal with PCI compliance, credit card information, all this stuff. Let me share you my slides. So we had a stack, which was our old clunky PHP MySQL app on top of Shopify that was not doing well. And we started moving everything to TypeScript, Node.js, Next.js, Hasura, Postgres. We also use BigQuery and Kubernetes. And Hasura comes in also connected to a lot of different tools, such as Payload CMS for CMS, HookDeck for us, observability on the events, webhooks and Pipedream for us to run a lot of serverless functions and actions without scale that as a service itself. It's almost like a prototyping tool. And we're also planning to use MongoDB and Timescale DB soon. What are the benefits of doing this? It's not a monolith. We have a separate the separate of concerns. Sometimes if something is faulty, doesn't mean that we will have everything faulty. And one of example of that is we had a downtime on Hasura because we forgot to put one environment variable a few weeks ago. And it was down for a bunch of hours, but users could place payments. They would get their confirmation of emails. It's just the orders were not arriving in the warehouse. And as soon as we fixed it, everything came through. So those are one of the advantages. We clearly saw that. And another one was pretty much time to order. We managed to reduce from over 30 seconds time to order to just less than a second or two. Now, those performance improvements, of course, they come with a cost, and usually this cost is also development time. But by using Hasura, we are able to quickly roll new features. We've been rolling features almost weekly, especially prototypes and things that we want to test later on with customers, but also internal tools and things for helping out our teams from finance, customer support, and etc. And connecting multiple databases make that easily, and we're maintaining also internal tools. Thank you for that. So what would be the things I would learn and have done differently if I knew this a few months ago? Use a lot of no-code or low-code tools. I consider Hasura almost as a low-code tool, but use more of that connected. Not use the other parts, for example, as I mentioned, some tools for creating some serverless or even no-code actions that really could speed up things even more. And the faster you try things, the faster you fail, the faster you figure out that's what we need or not need, or that's not going to work in scale. And the second one is, don't be, even though a lot of people say, Mark, you need to be microservices for e-commerce, not necessarily microservices. Our approach is a little bit like an onion. We keep adding layers on a service, and if it becomes too big or it's not doing more than one thing, we chop it down, break into little pieces. And I think that is what allows us to also move very fast. That's pretty much in a nutshell. We love to connect on LinkedIn and could talk for hours on this. And we just released our new shop, Bearskin Tactical, which contains a lot of new features that we've been developing for the past weeks. So take it a look and see if you like anything.
Gus, that was awesome. It's good to see a big step up from that PHP stack to a more modern implementation. I encountered a PHP stack over the weekend that terrified me, so nice to see that. All right, Gus, thank you very much for joining us today. I'm going to go ahead and share some final updates that we have, just a few small things, and then a couple of things to put out to you folks in the community. So just a few short updates here. First off, if you haven't noticed, Google Next conference was going on this week, and we were announced as successfully achieving our Google Cloud Ready designation for BigQuery, and then Google Cloud Ready for Cloud SQL under MySQL, PostgreSQL, and SQL Server. So a lot of cool things there. This means that we're part of the Google Cloud Ready program, and that we have a better opportunity to collaborate closely with Google as a cloud partner in engineering and all the teams on their joint roadmaps going forward. So we're very excited about that. Additionally, we have stored procedures now in GA for SQL Server. You can go and check the docs out about that information as well. And then finally, logical models and native queries have made their way into Snowflake. So if you're a Snowflake user, some exciting things there for you as well. Jumping on to our community updates, you know about the links that we have for everything else for the most part. We've got GraphQL Conf coming up on September 19th through 21st in San Francisco. You can go to graphql.org/conf to register for that. Tanmai has a keynote presentation there. It's called Is a GraphQL BFF Necessary in a Server-Side React World? And then we also have Marion, the head of our developer education, talking about why Relay is a must for your GraphQL APIs. Additionally, HasuraCon was a couple months back, but we have all these talks recorded and we're kind of progressively releasing them as well on YouTube. But if you go to hasura.io/events, you'll see HasuraCon 2023 in there, and you can go back and rewatch those things to your heart's content. And then finally, we have an event coming up called Deliver Applications and APIs Faster with Snowflake and Hasura. That'll be in about 2 weeks on September 14th. You can register online. And again, we'll have the link for you folks in the resources. Thanks so much for coming this week. Let me make sure that's the last slide that we have. Of course, we're always looking for feedback. And one of the things that I should say is we're always looking for great demos like Gus's today. So if you built something cool with Hasura or some kind of tooling around Hasura and would like to demo it to the community, let us know. There's a link inside even this presentation. And again, it should be in the resources over there. Or just shout at us online and we'll hook you up. So thanks so much to everybody that was being here today, and see you in September. Thanks.